We are the students of Chandigarh College of Engineering and Technology, and through this video we are presenting our project, The Right Turn.
The system we are presenting is a road safety device that is used to promote safe driving environment at blind turns and T intersections. It comprises of sensors, controller, transmitter, receiver pair and an LED indicator. The sensor checks the vehicle or pedestrian approaching the blind turn and giving response to the controller, which in turn transmits the same via transmitter to the receiver installed in the vehicle on the other side of the blind turn. This warning system provided has the advantage of simple structure with low power consumption, easier to implement, low cost, high reliability that can work all day and can effectively prevent vehicles from injuring passerbys or other vehicles in the turning process.
Now, beginning with the project explanation, we are first showing the design of the system through this block diagram. There are four major functional blocks: the sensor, controller, transmitter and the receiver. For sensing the incoming vehicles, IR sensors have been used. The control box consists of the op-amp and the controller IC, which does the necessary case analysis. The transmitter unit is used to transmit the necessary signal, which is sensed by the receiver present inside the vehicle.
Coming to the circuit design, the first PCB is the power supply, which runs on a required voltage or in the range of 6 to 18 volts and produces a 5 volt DC output. This is necessary to give the essential power required by the various circuit components. The sensors used for the prototype are the infrared sensors. These sensors work on the principle of reflection of IR rays from an object. It is a transmitter-receiver pair. Whenever there is some reflection to the signal sent out by the transmitter, there is a voltage change across the receiver which initiates the further processing of the control system. The control box is the main processing unit of the system. Here we are using Texas Instruments IC LM324 op-amp as a comparator. This works on two input voltages and produces an output after comparing the two values. Here we have also used potentiometer, which is used to calibrate the working range of the sensors. The controller used here is PIC 16F870. It is a 28-pin 8K memory IC working on 5 volt supply on the 28th pin. This PIC has been provided a 4 MHz oscillating frequency. The encoder used HT12V is a 4:1 encoder. It works on an input supply of 5 volts and is used for serial data transmission. Similar are the attributes of the 1:4 decoder HT12D used. For signal transmission, we are using C218D042A RF transmitter and receiver. This module works within a range of approximately 25 to 30 meters.
Starting with the working of the system. As the vehicle crosses the sensor, the infrared rays transmitted from the transmitter reflects back to the receiver, and there is a voltage change. This voltage is then connected to the positive pin of LM324, which is compared with the voltage on the negative pin from the potentiometer. After these voltages are compared, we get a high voltage state at the output pin. Similarly, all the sensors are individually connected to the op-amp. All these output from the op-amp are given to the PIC's input port. We have taken port B as the input port and port C as the output port. The PIC has essential program feeded in. We have used Micro C software for programming the kit. This is the programming kit used for burning and the serial communication between PIC and the PC. We have used Texas Instruments MAX 232. According to the signal received from op-amp, the PIC analyzes different cases and gives an output signal at the port C. This signal then goes through the encoder and is then transmitted through the RF transmitter. Now this signal transmitted will be received by any vehicle in the range of 25 to 30 meters. This received signal is then decoded and switches on the indicator and the LED starts blinking. For simulation, we have used RealPIC simulator. Here we have considered the case where a vehicle is crossing sensor C and a pedestrian is passing through sensor A and sensor B. This is sensor C, this is A and this is B. The LED which shows the output indication and the oscilloscope will show the switching of different points. Now when we press switch C and then switch A, within a time interval of 1.5 seconds, we see that LED starts blinking. This would warn the driver about the pedestrian. But if we switch C and either A and B is pressed after 1.5 seconds, then no LED will blink.
For implementation, we will be showing some of the possible cases. This is the sensor unit A, this is B, and this is C. As the vehicle passes through the sensor C, then if some pedestrian crosses sensor A within 1.5 seconds, then the receiver LED inside the vehicle starts blinking, thus warning the driver accordingly. But if we increase the time gap of 1.5 seconds, then we see that no indication is turned on. This time has been so chosen specifically because it will be enough for the vehicle to reach the intersection and thus be visible from the other sides. In the end, we would like to thank the entire TIADC team for their entire cooperation and time they devoted to us, especially Dr. C.V. Ravi Kumar, and in our institute, we would like to thank our mentor Ms. Harpreet Kaur for her guidance. Without them, it would not have been possible for us to complete the project. Thank you.